cloud computing, and I decided to call this one serverless design in cloud, because cloud is a little bit outdated concept in my opinion. Now we're getting to serverless cloud. Just cloud is not enough. First, what is cloud? Just in a few words, what is cloud computing? This diagram, it's not a diagram, it's a picture which explains what it means. We have cloud computing and we have on-premise computing. So on-premise is when you purchase your servers, you install them in the office or in a data center, you pay the full price for all the servers upfront, and then you get these machines inside the office, inside the data center, and they're yours. So you can install there whatever you want, install the software, you can configure them the way you want. This is your hardware. It's called on-premise. Cloud is when you go to somebody and say, I'm not gonna need the servers to be mine. So basically I rent them from you and you host them for me, and then you provide me the access to them. And you pay them per month. That's the general concept. Then we go into details and we see that cloud is something which many people still don't understand what it means, because the question, sometimes they do it like this. For example, you can go to Amazon and you say, here's my server, so I'm gonna ship my server to you, and you're gonna install my server there in your cloud, and it's gonna be my cloud server. It's also possible. So cloud is a difficult to define term, but in general there is a line between on-premise and cloud. I remember that I was working some time ago in a company where they needed to expand their platform because the traffic was growing, and the question was what to do with that. We needed more like 20 more servers. 20, it's quite large, like big amount of servers, and the question was between cloud, like Amazon or Google or something, or on-premise. And the decision was in favor of on-premise. That was 6 years ago, 5 years ago. Maybe today the decision would be different. But at that time, that was the decision. Instead of going to the cloud, instead of trusting the data to some other company, many companies still believe that on-premise is the better solution. So the main concern is security, I believe. The main concern is security, because you remember in case of Amazon what happened. We read it yesterday, that Amazon doesn't guarantee anything. So if the data is lost, stolen, hackers, whatever, they just guarantee nothing to you. So it's your problem.
But what about the cost?
The cost.
On-premise is more cost effective?
On-premise in sometimes it could be cost effective, sometimes it could be more expensive. So it depends on the amount of depends on the load you're going to put on the machines, depends on the time when you're going to use them. For example, if you need your machines for 3 months, then on-premise is more expensive. You buy them, you use them for 3 months, then you will try to sell them. The price will be half of the price you purchased them for, maybe even lower, so you lose the money. If you're going to use your machines for 2 years, then maybe in this case it's more cost effective. But still, ask yourself a question like, would you be willing to stay with the same machines for 2 years while faster machines will be on the market? So probably you will want to change your computers every year or something. But with on-premise stuff, you need to have them on board. And also remember that just having the machine is not enough. On top of the machine, you need to have a data center. So you need to have electricity, you need to pay for it. You need to have the security, you need to pay for it. You need to have this cooling, so the temperature has to be under control, because when you have 20 servers, you cannot just put them in the room. It will be too hot, so the temperature will be too high. So you need cooling, you need air conditioning, you need electricity, you need security, many things. And remember that servers, they actually sometimes break. So it's not gonna, one server is not gonna work for 2 years for you. I mean, one will work, but if you have 50 of them or 100 of them, then there's a guarantee that at least one hard drive will fail during the year. And you need the support to replace the hard drive. So you need somebody to watch your servers 24/7, every day a week, without no weekends. Don't go home. You need shifts. You need people to work in shifts so they can watch your hardware. If something goes wrong, the server is broken, the hard drive is broken, so somebody has to jump in and fix it. How much are you going to pay to these people? All of this will be taken care of if you go for Google Cloud or Amazon Cloud or Microsoft Azure or what it's called. So you will get this service for free. You only pay for for the time of the machines you use. So how much you need from the machines, that's what you pay for. So that's a trade-off. You need to decide which one to go. But on-premise is better. In most cases, which I've seen, companies make a decision for on-premise for security reasons. So it's more expensive in most cases. On-premise is more expensive than cloud. If you add all the costs together, then on-premise is more expensive because you're small, because you pay all of this much more than Amazon can pay. Amazon hosts thousands or tens of thousands of servers they have like a garage of I don't know, maybe millions of servers. Somebody claimed that Amazon has 1 million of servers, something like this, 1 million. So it's much more than any one of us can afford. So cloud is there, on-premise is here. That's the definition of cloud. And now the structure of the lecture. So first we're going to talk about Amazon Web Services. I believe this is #1 cloud platform. It was #1. It's still #1. So you need to know how it works, and then you will understand everything else. So no need to talk about Google and Microsoft separately, just enough to talk about Amazon. Then we will talk about Docker containers. This is, I believe, is major key component of modern cloud, containerization and Docker containers. Then about this one, PaaS, IaaS, SaaS, everything, this AAS. Who knows what it is, AAS? As a service, exactly. So we'll talk about this, what's the difference between them. Then we will talk about P2P computing, BitTorrent, blockchain, and maybe something else which may happen in the future. This is also part of cloud, I believe, because it's a computing which is happening over there. And then we'll, again, books, venues, and call to action. That's the structure. Okay, let's go. Amazon Web Services. The main one, we discussed that before. Yesterday, we talked about this Amazon, which is called Simple Storage Service, S3. Simple Storage Service. This is an example of the code written in Gesta language. What is the language here? No, try again. Ruby, that's right, that's Ruby. So in Ruby, for example, you want an object to be uploaded to Amazon's Simple Storage Service. You give the S3 client as an object. Bucket name is the name of the bucket there. Object key is the object key. So then you make a request, put object, it's called. Put object in the bucket, you give the bucket, in the key, you give the key. It goes there, it uploads, everything happens in the cloud. So in this case, there are no servers. There are no computers, so you don't know where are the servers, you don't know how many of them there are, you don't know about anything about the security, the air conditioning, anything. All you know is that somewhere there is a URL which you can use to upload your data, your object, and then you can retrieve back the object anytime you want. So that was the #1 service Amazon provided. So Amazon in 2002, something like this, like 20 years ago, they proposed this, they made this service, which was, am I right about 2002? Probably I am right. Okay, I'll double check. So that's, I think in this service we can see the whole idea of cloud. The core idea is that there is no server. We will get back to this again when we're going to talk more about serverless, but here, think about this, that maybe I have a slide about serverless. No, we'll later talk about serverless, but now the idea, the difference, yeah, okay, let's table this discussion for now. Next one is Elastic Compute Cloud. EC2. You know how funny they named their services. There was S3 because that's 333. This is EC2 because Elastic C Compute Cloud. Elastic Compute Cloud is something more practical for developers who need computing resources. So you basically make a request, and again it's Ruby. So you make a request and you say create instances. So create servers for me. And then Amazon EC2 will make a number of virtual machines for you in just a few seconds. Well, it's not going to be a few seconds, it's going to be about like maybe 20 seconds or 30 seconds. So you will have to wait a little bit, but on demand, they will create virtual computers, virtual servers for you, for your configuration. So for example, you right now need a huge machine with 200 gigabytes of RAM and a huge hard drive, and it has to have, I don't know, 60 CPUs, extremely fast. And you need this machine for just 1 hour. So you make a request to Amazon, and they give you this machine in just 20 seconds. It's a huge, powerful machine. You use it, you go to this machine using SSH, So they give you the access to the machine. So you open the terminal and you get to this machine. It's super powerful. You upload some data to the machine, you run some scripts there, they run on this heavy, huge machine for about, I don't know, 20 minutes, then you don't need this machine anymore. So you shut it down, you say, stop the instance. And Amazon just stopped the instance for you. How much you pay? $5 or $3. Because this huge machine, they cost $3, maybe $5 an hour. That's all. So you don't need to buy it, install it in your office, because that machine will cost you, if you have the physical machine like this, it will cost you, I don't know, $10,000. But you get it for $3 an hour. And you can make like 50 machines like this. The Amazon will just provide it to you in just one request. That's how powerful the cloud is. And then you release them also very fast. So many websites actually use this instead of getting servers in-house. Another service is called, I'm just listing you the services of Amazon which are interesting, which may be interesting for your development. There are many of them on Amazon. If you go to Amazon website, Amazon AWS, Amazon Web Services, you will find that they have, I don't know, probably now maybe 50 different services, while 10 years ago they had maybe 5. So they add new services every year, many of them, many different services. Each service, imagine it's a microservice. So you connect to this microservice through the API, you ask this microservice to do something for you. For example, like give me the server or store my data, like S3. And they provide you the service. Another one is CloudFront. Who knows what is CDN? CDN.
Content distribution network.
Content distribution network. So you probably know how it works. This is the diagram. Imagine if you use it, if the CloudFront is content distribution network by Amazon. So imagine you put your file, video file, into Amazon S3. It's a large 1 gigabyte video file, which you want many people in the world to see. And you don't want to use YouTube, so you want to do it yourself. So it's a large file. You upload it to S3 bucket. It takes, I don't know, half an hour for you. You upload it to S3 bucket, and then you want people from different countries to see this file from you. If somebody from an Amazon S3 probably keeps your file somewhere in California. I don't know, maybe, or in Amsterdam, we don't know. But when the user from Australia, for example, wants to download this file, then that user will have to go to the main server, to the main location of S3, and download from there, which could be, for example, in California, which is far away for Australia. So somebody from Australia will download this file very slowly because the distance is huge between Australia and California. To solve this problem, people decided to create CDNs, content distribution networks. The idea of CDN is that the file stays in S3 somewhere, but there are satellite locations, so-called satellites. So there's a core place with the data, and there are satellites, and there could be many of them. For example, CloudFront will provide you, I don't know, maybe you can see how much they promise. There is no number, but usually hundreds. Well, I'm not sure about hundreds, but dozens of locations, satellite locations. So you only go to CloudFront and say, you know what, I have a file on S3. So how about you take this file and place it in all your satellite locations? And CloudFront says, okay, no problem, like 1 cent for something, like $1 for each terabyte or whatever. You say, okay, I'll pay for you. So the CloudFront takes this file from S3, places in all the satellite locations, in Australia, in Russia, in Amsterdam, in South Africa, everywhere. So they have servers in each country. And then the user from Australia will download the file, not from California anymore, but from local server. Then you change the file in the main location, and the changes just automatically got spread over the satellite locations. That's the idea of CDN. Because the world is large, the planet is big, so keeping the file in one place is not good enough for distributed systems. So if you design the website, for example, and in your website you have many images, images, pictures, then it is very much recommended by web designers that you use CDN. And if you, for example, if you are the web designer, you know that if you use, let's say, jQuery or some other JavaScript libraries, then usually the URL which you use in your web page, in the HTML, starts with the CDN. So it's https://cdn.something.something. So because people place their files like jQuery.js or Bootstrap.js, different things, they place on the CDN. So they store it in one place and then it gets spread out through the CDN.
But what's the point? For example, here in the picture, there are lots of data centers next to each other. What's the point of this? Having several replicas of the same data
In different places, yeah, because it's faster.
in close areas. For example, in Europe or USA, there are.
It's still faster. If you have the file in Amsterdam or you have the file in Moscow, it's different speed. From me, if I sit in Moscow, I want the file to get from Moscow. I don't want my connection to go to Amsterdam and then return back. If you have the satellite here in Moscow, I mean, not here, like in Kazan, for example, then you will download the file a few times faster if it's a large file, comparing to when you download it from, maybe not a few times, but I don't know, 10% faster.
I think the latency is more important here because, like,
The latency, you mean the speed of connecting?
yeah, because usually the web pages are not that large, but you want them to load fast. So you want to reduce the latency, and for that you need to reduce the distance as much.
Right. Right. It's probably also about load balancing to some extent.
Yeah, load balancing, everything. It's just the idea is to move the content closer to the user, like territory-wise, closer, geographically closer. This idea is not new. Amazon did not invent it. Amazon just re-implemented the idea. Before Amazon, there were many other CDN providers, but now I think Amazon killed them all.
I think there's a lot of this.
Cloudflare, yeah, they also exist. But I think if you are the developer, most developers, if I would be a developer, if I need a CDN, I would go for CloudFront. Maybe it could be more expensive, maybe, than something else, maybe, I don't know. But I think Amazon is killing everybody now. Like with the services they provide, they just kill the competitors. Because if you keep everything in Amazon, you have your data in S3, you have your database in DynamoDB, which is Amazon service, you have your files in Amazon EC2, you have the server there. So it's like naturally more convenient for you to use CloudFront instead of connecting some other service, which you can get like Cloudflare, for example. It's another alternative for CloudFront. Another service is SQS, Simple Queue Service. It's also very powerful. I used it in a number of applications before. Simple Queue Service. The idea is this, that you, from one side, you can place the information into the queue, like chunk of data, some requests or some pieces of information, and then you make your servers take this information from the queue and process it. So it's the idea of decoupling the generators of information, the requesters, from the processors of this information. So let's say the user comes to your website, and many users, and they all send you images which you're supposed to, let's say you design the website, the web system, where I send you the picture, and you make this picture, you clean up the picture. So you make some filters, some like machine learning filters. So I send you the photograph, and you, using your filters, you have some special software which you design, so you clean it up. So you remove some noise, you make it look a little bit better, and then you return me the picture. It looks okay, like how you would design it. The first approach, the simple approach. I upload the image. When the image gets uploaded, your web script starts the processing happens, and then you return back to the user the answer. And the user is waiting online, waiting on the web page, expecting the answer. It's called synchronous processing of information, synchronous. So the user uploads the data, I wait for the server to process the data. When it's ready, I get back the response. It's okay while your server has not so many users. When the amount of users will grow exponentially, then you will realize that one server cannot handle all requests. So you have more requests than one server can handle. How can you make it possible for two servers to do the same? So you need two machines which will do the image processing. But there's only one web server. So the requests will come to the same web server. Let's say we have one web server. Of course, we can have multiple web servers, but one approach to organize this and to make this processing asynchronous. How do we do it? The request comes in, we put this request into some queue and tell the user, okay, wait for it. And then from the other side, servers, machines which know how to process the images, they connect to the queue, they pick up the information from the queue, give me more, first in, first out. They pick up the information from there, the image, they take the image from the queue, they make the processing, they return back the result to the queue, and then the web server says, okay, is it ready? Is it ready? Is it? When it's ready, it takes the result out and returns to the user. So we decouple them from each other. One piece of software places the orders in the queue. Another piece of software takes our orders from the queue, makes the processing, and places the results to the queue. And that was, again, not Amazon idea. Probably one of the largest open source projects for doing this is ActiveMQ by Apache. And Amazon, again, just killed this project. Killed this product because Apache MQ you need to download and install on your own server. If you don't want to do this, you go for Amazon. Here you don't need any servers. You just rent a queue. You just pay them some money for each message you place to the queue, for each message you take from there, and then the queue will do everything for you. So basically, it's like an array, like a simple array which you can implement yourself. But it understands concurrency, so there could be multiple concurrent connections to this array, and this array maintains the information in some layer, in some memory, which is not memory, in some persistence place, which is not destroyable. This is called System MQ, SQS, sorry. Another service which is interesting, the last one, which I wanted to show you, is Lambda. Lambda is not so long time ago, well, maybe a long time ago, okay, it's a few years for sure, the service introduced. This one, the picture actually perfectly demonstrates how it works. So let's say you have a contact form from the website. So the user fills up the form and says, please contact me. When I click the button, the form goes to, they call it API gateway. Then it goes to Lambda. Lambda is the service where you provide the script, and Lambda just starts a new machine, virtual machine, runs your script, and shuts down the machine. And it charges you for the minutes it spends on running your script. This is Lambda. So you give the script, you don't manage the server, you don't say, I mean, you say what kind of server you need, but you don't need the terminal, you don't want to connect to the server, you don't want to go there, upload the script, run it there. All you do is just to give the script to the Lambda service, and Lambda will just run your script with some configuration parameters and just shut down the server when the script is finished. It's a very convenient way to run some small, very small script, which will take maybe half a minute, maybe a few seconds to run. So you don't need, and you have huge amount of scripts like this, maybe thousands, maybe millions of scripts like this. And you need them to be executed one after another, and you're ready to pay for the time which the machines, the computers spend to execute your scripts. And then when this execution is finished, they send the result to one other Amazon service, for example, SES, which is emailing service, and then the email goes to the user, and the user gets some information.
Sorry, can you give a use case?
Can I what?
Give an example use case.
This is the use case. So you fill the form, you click button, and it goes to Lambda. Lambda, for example, prepares some documentation for the user, and this Lambda script sends an email to the user. So it's like, you know, when you have many requests of the same nature, and you need to process them through some pipeline, so you just get the job which needs to be done, you drop it into Lambda, and Lambda just does it for you, and it's done. It could be email processing. It's what? Renting a CPU, yes. It's like you're renting the CPU, and you don't pay for months, you pay only for the seconds which this Lambda is using it.
Then why can't we use, for example, same EC2, EC2 service, just create an instance, run the script that we need, and then shut the instance down?
Yeah, but in this case, you will pay for the server for a long time. If you rent the server, then it will just start working for you. You will pay for each hour, and then you mean to this server you will drop the tasks and they will work on the server.
No. For example, whenever I want to run some script,
you get the server, you rent the server, you run the script, and you shut down the server. That's exactly what Lambda is doing for you. So Lambda is just a wrapper around EC2. Yeah, exactly. Deep inside, it's still the same EC2. But Lambda does this extra work for you just to prepare and to shut down, prepare and shut down. You can write this script yourself. You can write these manipulations yourself. But Lambda do it just faster, more convenient for you. Okay, and to finish about Amazon, I can tell you that there is OpenStack. OpenStack is the alternative, open source alternative to Amazon, basically. So you can download OpenStack, install it to your computer, and you will have something very similar to Amazon. So you will also have S3, you will have EC2, the same API, but it's going to be on-premise. So it's going to be your servers in your office running the software, which on the client side, on the interface side, will look like Amazon. So it will be possible to connect there. So all the software which was designed for Amazon, most of the software, will work with this, with OpenStack. And this diagram, which I have no idea what's on the diagram, I'm just showing you this big. I found this diagram on OpenStack website. So they hey, this is our logical architecture. You as designers can already tell that this is garbage, like not a diagram, because nobody can understand what's there. This is not UML. This is how OpenStack presents their logical architecture. So it's a good example of a bad diagram, but you need to know that OpenStack exists as a solution. It's open source alternative to Amazon. Okay, enough about Amazon. So you need to, let me summarize, you need to know that Amazon exists. If you consider yourself a designer, you absolutely must know what Amazon is ready to provide you. So it's good to investigate, to learn the services Amazon can provide. At least the basic ones. I am using right now maybe 7 of them actively, while they have 50. Some of them I don't even know. I can say that maybe 7 years ago, I knew all of them. So I was like an expert in Amazon. I knew each service. I tried each services. But then I realized that they make new services faster than I can learn them. So I gave up. So now they have 50, and I don't really know what most of them are doing. I don't even know their names. And they keep adding more and more and more. I don't know where it's going, what's going to happen in the next 10 years, but now they have huge amount of stuff for everything, for blockchain, for gaming, for machine learning, for visual, for image processing, for voice processing, for different things. So they can give you anything you want. So you want your own blockchain, there you go. You want some machine learning platform where you will have your own models, you will be able to train them, there you go. They give you everything. Everything you need. So basically, we're moving to the direction of no code. So now you can assemble your software with the pieces provided to you by Amazon. Okay, Docker containers. I think some of you know what is Docker, right? I think many of you know about this. So I will be briefly telling you about Docker. Before Docker, we had products like Chef and Puppet and something else. Do you know about this stuff? The idea of Chef and Puppet was this. Let's say you have many clients, many servers, sorry. So let's say you are running the web system which has 100 servers, 100 servers, 100 machines, and each machine has Linux, Ubuntu. And then you're the administrator. So you realize, okay, I need to upgrade my Ubuntu because there's security update to some software, so I need to log into my server number 1 and run update the software. Okay, it works well. Then I need to log into my second server. Then I need to log into my third server. So then you need to do it 100 times. That will take a week for you to do this. And then you decide, okay, you know what? All my servers, they have something installed. For example, in each of them, I think I need to do backup. So I need to configure the backup scripts. So how do I do it? I go to one, configure it. I log into another one, I configure it. It's a lot of work and routine work, doing the same over and over again. So what they did, they invented Chef, for example. Chef is a server which stays aside from your 100 machines. All of them, they have special software installed there, Chef client. And these clients, they connect to the server, to the main Chef server, and ask the server, what do you want me to do? What do you want me to do? And you're sitting here and you're telling this server, how about you upgrade everything? Run this command there. And then all of the servers, they just run this command automatically. And they all report results. I succeeded, I succeeded, I succeeded, I failed. I succeeded, I succeeded. Okay, if one failed, 99 succeeded. Then you manually go to 19 to one server, check what's going on, and that's the amount of work you do. It's much less than doing everything for 100 servers. That's pretty powerful. It was pretty powerful approach. I believe it was before Docker. Then Docker showed up on the market, and we got containerization. We got Kubernetes and Docker, so no more of this Chef and Puppet. But that was really good software, written in Ruby, by the way. So Dockerfile in Docker. So what is Docker? Docker is the instrument of making an image for you, an image of operating system, so that you can start it and then just go into this image, and everything will be prepared for you just like you want it. For example, you install on your computer let's say, I'll try to give you an example. Let's say you have yeah, give me an example.
So, for example, once I made a model for using OpenCV to detect eye blinds, eye blinks. So for this Python script, I needed to download some dependencies, some packages. It needed some specific version of Python. So if someone wants to install this software, they don't need to install all these packages. I wrapped it in Docker, and inside this Docker, I specify which packages are needed, which version of Python, and so on. Exactly, it's a version. It's a
So basically, example is this. So if you need to run some software on your computer, for example, or on your server, then usually you need something to be around this server. For example, you need certain versions of the libraries to be installed on the computer. You need some version of Python. So 3.7 is okay for you, 3.5 is not okay for you. You need some version of some cryptographic libraries there. So something around your software. So your software always depends on some stuff. And the one approach is to remember everything that needs to be around. And every time, well, one time it's okay. You install everything on your server, you install everything on your laptop, and it works for you. But then you go to another server, and then you need to install everything again. And you may not remember exactly how you installed it for the first time, because installation is actually not usually a straightforward process. So you need some specific commands, some specific configuration. So it's not so easy. For example, installation of Python 3.7 is not so trivial for Ubuntu version 16. It's more trivial for Ubuntu 20, but it's less trivial for Ubuntu 16, and so on and so forth. So how you prepare your environment around your software is not a trivial task. Docker is saying you write Docker file only once. So you explain in Docker file everything, all the commands that need to be executed before we can run your software. And this is one example. This is my own Docker file. So this is the full script, and then on the right you can see just portion of it. Probably you cannot see it straight, but these are the commands which it's quite messy combination of commands, which I tested for a few hours. So I spent a few hours to create this script. But now I have this file, and I can run it always. It will always work because everything is tested and all the versions are fixed. So I can run it one time, and I get the so-called Docker image. So Docker image, it's a large file of usually a few gigabytes size. It's a pretty big file, which contains, it's a collection of files, but they call it image. So imagine it's one file, which contains the full image, the full copy of Ubuntu, plus everything I need for Ubuntu. So it's not like a clean basic Ubuntu, but plus the stuff which I need for myself. Python is there, Ruby is there, Java is there, all the things which I need. Yes, and then you start this machine and enter this virtual machine. And then you enter this virtual machine, and then everything is ready there, and then you run your software there. From what?
You enter the machine like a virtual machine or from
Like a virtual machine, yeah. You start it on your computer here on laptop, so you start this Docker image, and it becomes a container. And it's a container where you enter through the normal terminal, you enter there, open, boom, it's a console, it's a Linux machine, so you have everything inside there. And then you shut it down, you forget how everything is configured. In a few months, you start it again, you enter, everything is there, what you need. So it's a very convenient way to containerize your environments. So everything you do, you will do in containers. And now most web systems, not only web systems, data, everything, I believe now all serious development is happening in Docker. So people like already forgot this the idea of configuring anything manually. They just provide you Docker images, they provide you Docker files, and then you have it, and everything is there. So when you get a new server, the virtual machine, usually you get there and start a container inside virtual machine. So virtual machine and the container inside. And usually there are many containers. One container is doing this, another container is doing that. And each container inside is like a small operating system, like virtual operating system. Even in reality, it's not really an operating system. So this is the virtualization technology which was invented before Docker, which was called LXC for Linux. So LXC containers, they existed before Docker. So Docker didn't invent virtualization. Virtualization means that inside one Linux environment, you have like isolated environment and another isolated environment, but they cannot anyhow touch each other. So the process, this one can crash, this one can fail, and everything can go wrong. It completely can damage, like completely crash the one environment, but another one will be completely safe. So this idea of virtualization was invented by many products, but LXC was the Linux product, which is the core element of Docker. So Docker basically, it's a collection of scripts written in Go, which help you to start LXC. So Docker didn't invent containerization. Docker has no hardcore technologies inside. Docker is just a collection of scripts written in Go. So it's just a nice interface to LXC. So that was the innovation of Docker. So we knew LXC before, but then Docker showed up and made it more convenient and more user-friendly interface. And that's why it's a breakthrough of the last 10 years as Docker. But the real breakthrough was the containerization, virtualization and containerization of LXC. LXC, as it says, the Wikipedia is an operating system level virtualization method for running multiple isolated Linux systems on control host using a single Linux kernel. So there's a Linux single operating system, one operating system, but inside this operating system we say this is your isolated environment, another isolated environment, but they don't conflict anyhow, don't clash, yeah.
How is it different from virtual machine?
How is it different from virtual machine? Virtual machine is
It's a full system virtualization. The virtualization is more kind of lightweight. You don't emulate all the hardware that you have in the machine. You just say, it is implemented in the Linux kernel, and that just allows you to do some APIs. But if you do the system implementation, the virtual machines, you will implement the hardware, kind of isolated hardware. So it's different levels of virtualization. And actually, containers are just more lightweight because you don't make it stuff.
Yeah, that's a good answer, but I think if you want a shorter answer, then containers don't boot the operating system, don't start the operating system. Container starts in 1 second. So to make a new container in Linux, it's just like this, boom. It's not really making anything new. It just says, okay, you have the idea of your container is 1, 2, 3. Now make a new process. Then you say, okay, run the game. And they run the game in the same Linux, but it just limits the possibility of your process. So you stay within the same operating system. The virtual machine starts a completely new operating system. it boots. It takes half a minute, maybe 1 minute to boot everything, to load the new kernel, to start this kernel, to let this kernel, to give this kernel the control. So it's much larger operation. It's much heavier operation. Virtualization happens inside existing, like it says here. Multiple isolation hosting using a single Linux kernel. A single Linux kernel. So we don't go away from the Linux kernel. We run the same operating system. While virtual machine is managed like this. So we have the computer, the server, and then you start the virtual machine giving some resources. Like this CPU is yours. This amount of memory is yours. So you work only here. Okay, that's another virtual machine. These 2 CPUs are yours. This is amount the memory is yours. So this is done at the level of the hardware, I would say. So at the low level, we control access to resources. When we do virtualization, the containers, then this control is happening on the software level. I'm not really an expert here, so I'm sorry, maybe I'm giving pretty vague definition of that, but that's a good question, actually. I was also asking myself this question. You need probably to read about this. So, but you're right, we have virtual machines and we have containers. It's like 2 different levels. Virtual machines are like hardware, more like hardware level, operating system level, and virtual and containers are at the level of inside one OS.
I remember this question, this exact question was a part of our distributed system course, so from the last year. So the main difference is the layer where this software exists. So the Docker does not create a new kernel, like it
Doesn't boot anything.
yeah, it doesn't put anything. It just connects with the existing kernel.
The existing kernel, yeah.
But virtual machine creates the kernel from scratch.
Virtual machine is like a new operating system. New kernel is loaded. So you can have, for example, Windows and Linux working on the same server. This is Linux booted here, and this is the territory for Linux. These are the amount of CPUs. This is the amount of memory. And this is Windows working on the same machine, taking another set of resources. Okay, the last point about containerization, Kubernetes. Kubernetes is also a trend right now. It's also a hype, which is helping us to manage containers. So again, the task is this. Imagine you have 100 servers. And on these 100 servers, we have 100 containers, or maybe in each server, you have 5 different containers. So it's the similar problem as we had for Chef before. But now we have not virtual machines, but we have containers. So Kubernetes is like a master. They have Kubernetes master, another machine, which is looking at all the containers running on all servers, and you can control it from here. So you can say, I need 100 containers. And Kubernetes will start those containers with the software you need inside those containers. And then one container shuts down because it happens. You know, Docker is not really stable. Well, now it's more stable, but it wasn't stable 3 years ago. So containers were losing control and they were shutting down for some reason, or hanging up. So there were problems. And Kubernetes was solving this problem. And instead of manually starting the containers, Kubernetes is something that you definitely need if you have more than 5 servers, maybe even if you have 3 servers. At this point, you also need, containers, yes. Even if you have, that's a good comment. If you have 1 server, and inside 1 server, you're planning to run 5 different containers, then Kubernetes is also a good solution for you.
It's like Chef, but for containers.
It's like Chef, but for containers, yeah. Chef was good for virtual machines. Now we have containers. Okay, we have Kubernetes. Next topic is this PaaS, IaaS, and blah, 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 blah. So do you know what they are? PaaS, IaaS, SaaS, yes, what this is. We know that this is as a service. The last one means everything as a service. EaaS, yeah, it's called everything as a service. The first one is platform as a service. The second one is infrastructure as a service. Then software as a service. They started from software as a service. So originally the only one was software as a service. And I believe the first one who made it up was Salesforce, if I'm not mistaken. So that was the platform which suggested to use this software as a service concept. That was like the pioneer platform. They were saying that you don't need to install, Salesforce's CRM system. It's a CRM where you manage your customers, customer representation management, representative management. So they were saying you don't need to install any software on your side. You just rent Salesforce, and then you need some extra software, so you take it from the marketplace. So we give you the marketplace. You rent your software from the marketplace. We get it installed. Everything works. So it's software as a service. You don't need to get it on your computer. You rent it from us. So this is the picture which more or less explains what it means. IaaS, PaaS, SaaS. So there are 3 layers, basically. That's what you need to know. On the basic level stays IaaS. So you come to the provider and say, give me the infrastructure as a service. EC2, Amazon EC2 is exactly at this level. Give me the virtual machine. I pay you $3 an hour. They give you the virtual machine. This is the basic level, infrastructure as a service. We don't buy infrastructure, we don't buy servers, we don't buy these shelves, we don't buy the room for the servers, we get infrastructure as a server. Virtual servers, storage, load balancers, networks, everything. Infrastructure, that's the first level. The second level is called platform as a service. Platform as a service is more like Heroku. So Heroku stays at this level. So you come to Heroku and say, don't give me servers. I don't want to rent servers. I give you my code, run it. I give you my Java code, turn it into a website. Database. You go to the system and say, I don't need a server where I will install my Postgres. Instead, give me access to Postgres. I need Postgres with 5 gigabytes of space, and I need it now. Okay, they just wait. In a few seconds, they give you Postgres, where you can connect through the API, through the IP, and then through the API maybe, or through the IP, and you use it. This is platform as a service. So they give you the platform, like database execution runtime. Heroku, MongoDB also is provided like this. So many things they provide like this. And then the last level is software as a service. In this case, you just connect to them and say like Salesforce. So you go there, Gmail. Gmail is software as a service. So you don't come to Gmail and say, hey, give me the database with emails and give me the software which connects to the database with emails. No, you just say, this is my login, this is my password, make me the login and password, give me the email manager, online email manager. Gmail is a good example of software as a service. Gmail, Google Docs. Google Docs is software as a service. So you basically rent the software online. The Gmail is free for us, for people. But if you're a company, then you can go to Gmail, to Google Docs or Gmail, and pay them good money, and they will give you everything for your company. So you will have your you have your emails of the company. They will give you private area where all your docs are private. It's specially designed for you. It's not going to be named Google Docs anymore. It will be your docs. You will put your logo there. There will be your private logo staying there. So everything will be designed for you. The Gmail will look differently. So it will be Gmail with the logo. The logo will be your company logo. So this is software as a service. They provide you the software. You don't buy it. You don't get the license for it. You don't buy it and install on your computers. They stay somewhere. It stays somewhere in the cloud on their servers. But you only pay for the usage. They will charge you like $50 a month or something, or maybe $50 for each user. I don't know. It's pretty expensive. So Google for enterprise, it's a pretty expensive platform. For us, it's cheap for individuals, but for companies, it's pretty expensive. So, and then you can do everything as a service. Like every time you rent something, this is as a service. Samokat is a service. Car sharing is a service. Car as a service. This bike as a service. Whatever is a service. That's why they sold everything as a service. This is just another word for renting, for rental. Every time you rent something, it's as a service. That's all you need to know about this. So I wanted to show you about Heroku, to explain this concept of platform as a service. So in Heroku, let's say you're the Heroku customer, you create the software, you push it to Heroku. Heroku does the provision, they call it provision, so they start some server, maybe a number of servers, and then on this server, your resource works. I mean, your product which you design. This is platform as a service. So the whole platform is provided to you. You don't know about infrastructure, you just give the platform. So let's talk about serverless, the main topic which I wanted to present you today. So serverless architecture, it's very much hype about this serverless architecture. Basically, the core idea is it is function as a service, FaaS. You see there. So how I understand serverless, different people understand it differently. Let's put it this way. So if you read about serverless architecture, you will be confused, like I am confused. So every time you read something different, every time they say something different things about it. How I understand it. Let's compare two approaches, Amazon RDS and Amazon DynamoDB. How RDS works. RDS is based on, as far as I know, it's MySQL or Postgres, but let's say you like to work with MySQL. So you go to Amazon RDS. RDS is you rent the database. So you say, I need a MySQL database, and I want this database to have 1 terabyte of space. So give me the database. They say, okay, wait a second. You wait for a few seconds, maybe a few minutes, and then they give you the IP address of your database. So they say, okay, here's the server where database is installed. So you don't need to log into the server, but here's the server, and there's the IP. Connect to this IP, you have the database. We charge you for a month. As long as this server up and running, we're gonna charge you a few dollars every hour. Good? Good. Work with this. That's one approach. I believe this is not serverless. And now the serverless approach, also for data management. You go to Amazon DynamoDB. In DynamoDB, you say, I want to have a table. Make me a table. Call it books. Okay, books is there. And then you say, okay, I have a vacation. I'll come back to you in a month. You go for a month, you come back, zero, nothing is charged. They don't charge you anything. Okay, table is there. Then you say, I want to put 50 million books on the table. You just make a request and send 50 million books to the table, like records. And they say, okay, now we charge you $2 for the upload, because you uploaded so many books, okay, $20. Then you say, okay, keep the books. It stays on the table. Again, you go on the vacation, you return back in a month. They say, you know, we were keeping your books for a whole month, so how about we charge you another few dollars? Okay, then you delete the books, it's empty, again, zero charge. So every time you need some function for you to be done, you request this function, they do it for you, but there are no servers involved. So you don't know how many servers were keeping your books. This information is hidden from you. Maybe one server, maybe two servers, I don't care. I don't even know the IP address of my server. This is why it's serverless. So in the first example, I knew exactly the IP address of my server. And I pay for this server. I pay for infrastructure, basically. I pay for the machine. In the second example, I don't pay for the machine. I pay for the function. This is my function. Store the books. Delete the books. Retrieve the books. Calculate how many books. So every time I make a request, I pay for it. It's okay. But I don't pay per month. I pay per feature, per function. Okay, this is the function. Store my books for a month. But don't run my server for a month. Store my books for the month. That's the difference. So every time, my bottom line, every time you see the IP of the server, IP address, it's not serverless. So the trend right now is to design systems so that there are no IP addresses involved. So you never know which servers are running for you. For example, Lambda example, which we discussed, Lambda in the Amazon. So you give the script, some server run your script, but you don't know which server. This is serverless. Another approach, give me the server and I will run my script there myself. This is not serverless. So the trend is to make them serverless. And the link is to the original article published on Martin Fowler website, where they introduced this term, serverless architecture. I think it's worth reading this article. And you must know about this serverless architecture. Okay, now we're jumping to fun stuff, P2P. Who knows what is P2P? But can you explain P2P, what it is? What is P? Peer-to-peer, right. What is peer-to-peer? What does it mean?
It's when the communication happens, like there's nothing, no central server.
No server, yeah, no single point of contact. So we don't have a central point like this server manages us. Nobody, like no central point of contact. I send you, you send him, you send me, and that's it. If you go out of the network still functions. So there's no central point of failure. The first one is BitTorrent. BitTorrent, you probably know what it is. You maybe downloaded something from there. So it's a large network of individual computers, servers, all the participants. All they know is the addresses of servers which stay next to them. So they know their neighbors. That's all they know. I know my neighbors, you know your neighbors, so you just know who are around us. We don't know the whole network. So nobody knows who participates in the whole network. Like sometimes there's a segment of the network which stays in Australia, for example, and we stay in Russia, so we may never connect to Australian network because we just don't know where they are. So there is not even central catalog of all participants. So you cannot connect to some place and say, give me the list of all participants who are now online. No, you can only know a few neighbors. So it's decentralized network, and I believe this is the future of computing. So we will have more and more systems like this. So BitTorrent was good for files, for file exchange, where people basically exchange some stolen content. But blockchain is more serious stuff. Blockchain is the system. Who knows how blockchain works? Like really, you can explain what's inside. Or you just understand it's a good stuff for money laundering. Something like this, right? So blockchain, it's pretty interesting technology. So Bitcoin is a money pyramid, but blockchain is something which really technologically wise is interesting direction. It's not so complicated. So blockchain should not make you, should not scare you away. Did you have a course about blockchain here? No, but maybe you will in the future. No, I mean, I suggest, I have a presentation on my YouTube channel about blockchain I made a few months ago on the HighLoad conference here in Moscow, where I explained how blockchain works in simple words. So I highly recommend you to watch it. It's like 40 minutes of talk, and I say it in Russian actually, how blockchain works how it works technically, how it's designed. So the idea is quite simple. So we have many computers, and each computer has the full copy of the database, and when something needs to be added to this cumulative database, then the information comes to one server, and then the server, and it gets spread to many servers, and then they stay for a few minutes trying to calculate the right position of this information into this general database. And when the position is found, I'm saying this in primitive terms, when the position is found, when one of them manages to calculate how to put it properly into the database, then it tells everybody, okay, I found the way, so now we put it to the database, they all copy these changes to all databases, and now that the whole database has a new information. And if somebody drops out of the network, and if somebody starts lying about the information, for example, some server is corrupted and some server is trying to steal the money and fake the information, then other servers will say, no, we don't trust you because we all know that there has to be $5 on this account, not 50, because there are many of us and you're just alone. And because there are many participants, it's very hard to steal some information because always the majority will vote for the right information. So if you join Bitcoin network and start stealing Bitcoins from some trying to take some money from one account and move to another account, then the rest of the network will just reject your information. You can spread it over. You can start pushing this information to the network, but they will reject because it's not going to match with what they have. And that's it. End of the story. So this is the network where the majority is always right. So you can actually steal Bitcoins. You can make huge, like billions of dollars. But in order to do that, you need to have so many computers as the rest of Bitcoin network has. And right now they have, to some estimations, about 2 million CPUs. So something around 2 million CPUs. I definitely not accurate in this, but approximately the order of magnitude is right. So there are millions of CPUs running Bitcoin servers right now. So if you want to beat them, if you want to steal them money, you need about 2 million CPUs, and then your computation power will be as large as they have, and you will be able to damage them and take all the money.
Can this be done with virtual machines?
You can have virtual machines, everything, but how much you're going to pay for these virtual machines? So it is possible. Yeah, it doesn't matter which kind of machines you have. You just need similar amount of resources like they have, and in this case, your information will be more trustable than their information. And these machines will trust you more than they trust their neighbors. And then you will take away the money. But that's, people say it's technically impossible. You will not be able to purchase this amount of machines and so fast. And if you do that, they will just walk away and say, okay, Bitcoin worth nothing because it was stolen. Bye-bye. So you invest so much, you take these Bitcoins, but then the next day Bitcoin will cost nothing because we all understand that it's all yours now. So something like that. So it's a discussion for, for a different place. But the direction is definitely right. So I believe that in the future we will have more and more systems like this. Systems where we have no central place of control. We have no point of failure. We have individual machines running by volunteers, running by people who we don't know, anonymous people. They have their own software. Sometimes I actually, I was interested in this direction and I created my own cryptocurrency a few years ago, my own alternative cryptocurrency, which is different from blockchain. So I was reading about blockchain. It's an interesting concept. So I was thinking, how about I make something similar, but without blockchain, so not a blockchain. And I created this cryptocurrency. It's still running. It's up and running. We have about 30 servers right now, volunteers, just only 4 servers mine, and the rest servers from somebody who I don't know who they are. So I created the software which is installed in each computer, and the software exchanges information from machine to machine. And in order to shut down this network, you need another 30 servers in order to to corrupt the information. And I can tell you what's funny is that when the software I made was pretty well, I made it in Ruby, programming language, and it was quite well because the core element of the software was written in C, so it was quite fast. And for the system, it was to get the control, to get the trust in the system. The system is designed the way that we trust the fastest computer. So who is calculating the faster, then this computer is more trustable. That's quite simple concept. So there was a volunteer, some guy who I don't know, who created a copy of the software. He took my software and copied that. I mean, not copied, but redesigned it completely from scratch. And he installed it on his own servers and runs it there. And it runs 10 times faster than my software. I don't know how he did it, but it's 10 times faster. So now his servers is actually control the network. Well, I have my servers, they have special status, so nobody can ruin the network, but his servers go after my servers. So all the profit, all the benefit in the system goes to his machines. So he's making all the money in this system. So that's an example that it's completely out of control. We don't know who they are. We just know that they're volunteers. They can design their own way. The only requirement is that the protocol has to be the same. So he made the software which talks the same way, like all my software. And now we have the network of 2 types of software, my software and his software. And he's got a number of servers which are 10 times faster than mine. Cool? Cool. Okay, I think this is the future. So we are finishing books. For the books, I recommend these 2 books. Actually, this book on the left is the study for Amazon Certified Cloud Practitioner. It's a certificate. So if you want to be really professional in the area of cloud, I suggest that you get the certificate. You read these 2 books, and then you get this AWS Certified Solution Architect. So you pay about $250 to Amazon, you study the book, you go to the exam, and then you fail probably, like I failed 5 years ago. So I tried that, it's my story of shame. So I tried that, I paid them the money, I studied. I thought that I knew Amazon. I thought I know Amazon very well because I was a user, active user. So I studied a little bit, then I went to the exam and they started asking me questions about network configuration, how to configure this, configure that, and I was, oh, sorry, this I don't know. And they failed me. So that was one of the certificates which I failed.
Why most of the certified people I see AWS and Azure certified?
Yeah, you will be and Azure certified. Yeah, but probably Azure also has it's Microsoft, the same like Amazon, but from Microsoft. Azure, I think it's Azure. What's Azure? Right? Yeah, Azure is the right name. So this is the platform, the same like Amazon, but from Microsoft. Azure. Yeah, and they also provide certification. So when the company will hire you, they will ask you, okay, we have 100 machines on Amazon and many different services. Are you certified? And you say, yes, I'm certified. Okay, come in because we know you will be able to manage our network. Call to action, use 2 web Amazon services in your application. That's very simple. So when you have your application, just use 2 services and have fun. Simple as that. Okay, unresolved issues like usually. First one, how to simplify serverless design. We're just in the beginning of this serverless trend. So how to make it simple? Because now it's pretty complex to design these serverless applications. Nobody knows how to do it. Second one, how to manage data serverless. Because like I said, in most cases, people give you database servers and then the database is installed there and then you have the IP connect and manage. It's your problem. So we thinking how to do it, how to manage this data in a serverless way. Second one is how to decentralize better than blockchain. This, I think, will be the question for the next 10, 20 years for many generations, maybe down the road. How to make something more interesting than blockchain, because blockchain has many problems. Blockchain is not perfect at all. So blockchain is very popular because of Bitcoin, but technically, if you look at how it works, it's an architecture with a lot of defects, with a lot of serious defects. For example, blockchain and Bitcoin will never be fast. So Bitcoin will always process your transactions in at least 10 minutes. So when I pay you, we need at least 10 minutes so that you can get the money. But usually to trust me, if I pay you a lot of money, then we need at least half an hour. And it will never be faster. So that's the fundamental limitation of blockchain. Another fundamental limitation is blockchain is growing in size. So every year, this whole database of Bitcoin is growing probably, 10%. So in 10 years, it will be a few terabytes of data. Now it's already, I think, like 300 gigabytes or something, the whole database. And each server which works in the network has to have the entire database. That's a huge limitation. So you cannot install a Bitcoin server on the mobile phone or on the watch.
I think some blockchains have so-called light nodes where they don't have entire process.
Yeah, but that's we have this light nodes or light network. Yeah, but that's a workaround because this light only it can process the transaction, but will be no trust. So the core element of blockchain, which is trust, will not be gained in this light network. We can send some transactions, but the trust is not there. So there are really big fundamental technical limitations on blockchain, which are not solved. So that's for the future, for you, how to make systems which will be not blockchain, but will achieve the same goal. The decentralized storage of financial data, of, medical data, of traffic data, of some government data, of personal data, many things which we in the future will need to store in decentralized way. So systems where one server and many clients, it's going to be the past. The future will be BitTorrent, blockchain, something like that. So you will be the people who will invent one. If you invent something like this, you can be as rich as these Bitcoin guys who invented Bitcoin. So that's the direction for the future.
So any Bitcoin user, like a Bitcoin user, should have all the database about?
If you want to be part of Bitcoin network, then you will have to have a server with 0.5 terabyte of data on your server, yes.
And these are called as mine Bitcoin.
Then you will mine the Bitcoin. Yeah, you can mine Bitcoin. Yes.
To mine it, you don't have to have all the data. Actually, you can join some pools and they do it.
Yeah, but you can mine if you have the full data. But still, if you want to be the member of the network, you need to maintain the full copy of the data. So this is like a huge redundancy in Bitcoin. Imagine they have right now approximately 10,000 servers. I said 2 million CPUs, but like CPUs, there's more CPUs, but less servers. But still, 10,000 servers right now in the world for Bitcoin. 10,000. And each server has the same data. You see how much duplication of data we have in the world. It's complete craziness. Like, why do we need to copy the same data so many times? It's crazy. They say that in order to process one transaction in Bitcoin, we spend the energy, which is enough to warm up the house for a month, like a house for a family, really, for one transaction. So that's how much energy we spend to maintain Bitcoin network.
Then how do these servers make money?
How they make money? Well,
if they are consuming a lot of energy.
Because they mine, they process transactions, so we pay for it. Each transaction in Bitcoin right now costs $10. So to send money, yes, in order for me to send you $10, I have to pay 20. So each transaction is $10 each.
Is one transaction like $10 enough to warm a house for 1 year? You said like one transaction will make energy, like will produce energy enough to warm a house for 1 year. Like it's that much of processing.
In order to process your transaction, we put transactions into blocks. That's why blockchain. So you send transaction, he sends transaction, I send transactions. They accumulate the transactions in the blocks. Usually it's about 1,000 transactions. So we pay, each of us pays $10. So that's $10,000. On top of that, each block makes 6 Bitcoins, which is about $50,000 each. So it's $300,000 they make every 10 minutes. $300,000 every 10 minutes. That's how much Bitcoin makes. 300,000 every 10 minutes, dollars. That's the cost of Bitcoin. That's how we pay, because the price goes up. So because, I mean, they make these new Bitcoins and the price stays the same. So people who maintain the network, they make 300,000 every 10 minutes, every 10 minutes, every 10 minutes. So that's crazy what's going on.
But other cryptos, do you also pay a transition fee for transferring?
In different these coins, they have different approaches to money. Some of them are free, but you pay for mining. Some of them are different. I don't know. I don't even want to investigate. I look at Bitcoin. In Bitcoin, I know what's happening in Bitcoin. So in Bitcoin, it's very expensive network, very expensive. In the future, we need something cheaper. We need something which we can run on mobile devices. Then on mobile device, I can run this software. But Bitcoin software is extremely heavy. It's extremely difficult to run, to maintain. All right? Okay, so the final step is how to enable decentralized, final question, how to enable decentralized computing on IoT devices. This is what to think, like we just mentioned, to think for in the future.